Hello. Today we're going to be talking about solving systems of equations with elimination, or using the elimination method. All right, now let's jump into an example problem here. Okay, so let's say I have this system of equations, and I'd really like to find a solution that works for both of these equations. Okay, I want an x and a y that I can plug in to both of these equations to make them true. Well, the last thing we learned was solving systems with substitution, which involved taking one equation, solving for one variable, getting something in terms of the other variable, plugging that back into the second equation to eliminate a variable, and then going through and solving and doing all that mess. And that's great. That sometimes that works really well, but there's an easier way. Now, because these two things are equal, x minus y is equal to 6, I could add 6 to this side of the equation, to 24, and I could also add x minus y to this left side of the equation. Because these things are both equal to 6, I'm doing the same thing to both sides. So I can do that. What I'm trying to tell you is you can actually take these two equations and add them vertically. So 2x plus x is equal to 3x. Y plus negative y cancels out, and 24 plus 6 is equal to 30. Now, what did that accomplish? Well, something pretty big. It got rid of my y. I'm left with one equation with one variable, and we can solve that. We can get one solution here. Our solution is going to be x equals 10. And just like we did before, we're going to go ahead and plug this 10 back into, I would do this equation, x minus y equals 6. Okay, and you can kind of see that y is 4, but if we add, I don't want to do it that way. Just go through the steps. Negative y is equal to 6 minus 10 is negative 4, and y is equal to 4. Okay, so I have my solution here. X equals 10, y equals 4. Now, if you watch the other video, you can see that this was a whole lot less work. I mean, I literally have like 3 steps here. So it's really nice. Sometimes when you can add two equations together and get a variable to cancel, it makes for a much easier problem. Now, what do we need to be able to add two equations together like this? Well, the coefficient for this y, even though it's not written, would be a 1, and the coefficient for this y would be negative 1. So we need coefficients which are opposite each other, so that when we add the equations, that variable cancels out. Okay, let's try another example here. Let's take a look at one where, well, I have a little bit of a problem here, and that problem is these coefficients, if I add them together, nothing cancels out. I don't have opposites. Well, that's easy to fix, because all I need to do is I need to multiply. Let's choose a variable. Let's say that I want these y's to cancel out, okay? So all I need to do is I need to multiply this equation by something. I want to multiply this 4 by something, and I want to multiply this 6 by something, and I want them to be opposites of each other. So I want them to have the same absolute value, like, 10 and negative 10, but I want them to be opposites of each other. So what I'm going to do is I'm going to take the least common multiple of 4 and 6, which is 12, and I'm going to make one of these positive and one of these negative. So let's take this top equation. I'm going to multiply this top equation by negative 3, and that will give me negative 9x minus 12y is equal to a positive 3. Negative 1 times negative 3 is positive 3. Now the bottom equation, I also want a 12 in the y's for the y's coefficient. So here I'm going to multiply both sides of this equation by 2. And, okay, let's go ahead. Negative 10x, let's see, plus 12y, 2 times 6y, equals 27 times 2 is 54. All right, great. Now, what we accomplished there was by me multiplying the top by negative 3 and the bottom by 2, I got my coefficients to be opposites of each other, negative 12 and 12. That's great. Now when I add these things together, the variable will cancel. So let's go ahead and add these two equations together. Negative 9x plus negative 10x is negative 19x. These two cancel just like we wanted them to, and 3 plus 54 is 57. I'll divide both sides of this equation by negative 19, and 57 divided by 19 is 3. One negative sign means negative 3. X equals negative 3. So what I'm going to do now is the same thing we always do once we have half our solution, is we plug this x into one of these equations and solve for y. I'm going to choose this one here, the 3x plus 4y. This is going to be 3 times parentheses negative 3, okay, substituting negative 3 for x, plus 4y is equal to negative 1. I'm ignoring this times 3 thing. I'm just writing down the original equation and substituting negative 3 for x. Okay, negative 9 plus 4y is equal to negative 1. Add 9 to both sides. 4y is equal to 8. Divide by 4. And y is equal to 2. So my solution would be x is negative 3 and y is positive 2. All right, now as you can see, we really accomplished the same thing that substitution does, which is getting rid of one of these variables. But solving with elimination can oftentimes be a lot easier and less steps. Okay, good luck.